Hi, and welcome to the end of the first lecture for the 8th period class. This is the earlier class that I teach. The classes left off at different places, so I'm going to put up a video for each place. As I will tell you in the email that I send out, this is because you will be having a substitute on Tuesday, Professor Sversko, and you'll be doing in-class work for those periods. Anyway, I wanted to start by reviewing something that we went over briefly from last class called the parameterized optimization model. Okay, and we talked about what a parameter is. Remember, this is sort of like the the example I gave you was the amount of flour a chocolate cake requires, or the amount of flour a vanilla cake requires, under the sort of idea that what if we started changing around the recipes for chocolate cakes or vanilla cakes for Farmer Jones. So we start representing those constants in the model with a symbol, f of c or f of v in this case. Please note, parameters do not change through the solution of the model. So when you solve for the decision variables, they are not a decision variable. Okay, so a parameter is not or are not decision variables. Okay, that's a very important distinction. However, they're going to look like it sometimes because we still will use symbols to represent them. And a parameterized optimization model means a model where one or more of the constants are parameters. Okay, that changes the model in a sort of interesting way. And so I'm going to try to illustrate this with an example that we have on the last page of these notes. So let me zoom over there. Okay, so you'll note that another way of calling this is abstract or concrete. This semester we're using parameterized or not. So don't worry, sometimes the notes will still have abstract or concrete from last year. I'm doing my best to update them so they don't have that, but if they do, please, and if you're confused, ask me any questions, and I hope this doesn't cause any confusion. Anyway, so are the models given here linear programs or not? Are they parameterized or not? So I want to, because we just started talking about parameterization, let's first answer that question. So when we look at this first model, we can see that, okay, to see if it's parameterized, you just look at all the constants. Okay, so the constants, so this is a model over Z1, Z2, and Z3. Okay, so that would have to be given to you, that the variables here are Z1, Z2, Z3. Okay, so we're given that information. To see if this is a parameterized model or not, we just look at all the other information in it and see if there are any more symbols. So 3Z1, 3 is a constant, no. 14, not a symbol. 7 is not a symbol. 10, no. 5, 25, 18, negative 18, no, it's fine. 1, 1, 1 in the zeros. No, so it's not parameterized. Okay, now are the functions linear? Well, the objective function is, I just see, yeah, that looks fine. The constraint here is definitely linear, and all these are linear, so this is indeed a linear program. Note that the inequalities are all weak too. It's greater or equal to, greater or equal to, greater or equal to, less than or equal to. Again, the thing that might cause it not to be would be like a strict, like if one of those had been strictly less than, then it would not be a linear program. Okay. Let's look at this here. Minimize, let's C be a given constant. Okay, so already off the bat, we should be thinking, wait, this might be parameterized. And we see it's used here. And, a tricky thing, and I probably won't pull this on you, a tricky thing would be to not tell you that C is a given constant. I won't do that. But anyway, that means it's parameterized. So right off the bat, we know it's parameterized. And let me just also tell you one thing else is missing in the description of the problem that you should ask. So if you get this kind of problem, you should stop and say, Professor Phillips, what are the variables of this? What are the decision variables here? And the decision variables here, W1, W2, and W3, okay? So these are decision variables. Okay, and I will do my best not to leave you hanging on this kind of question in a quiz or a test. Okay, so then we look at this. Okay, that looks linear. We know it's parameterized because of the C. See, it just needs one. We can see that, oh my, like there's here, that's nonlinear. Okay, this is linear. And this is definitely an integer, this is a discrete model. So it's not a linear program. I'm going to say it's not an LP because that's our abbreviation. Let's get Farmer-Jones model. Okay, so Farmer-Jones, let's see, we had 3C. Let's see, where did we have Farmer-Jones model? Where are we here? Here we go. Here's Farmer-Jones. So let's look at Farmer-Jones. Looks like we have 3C plus 4V, that's linear. 4C plus 6V is less than or equal to 48, linear. 4C plus 2V less than or equal to 32, linear. CV greater or equal to 0. It is linear, and again, I want to emphasize the inequalities are all weak inequalities. They're all less than or equal to or greater or equal to, okay? They're not strictly less than or strictly greater than. So cool. We have, indeed, Farmer-Jones model is linear. So I'll just say it's an LP, but not parameterized, because the way I wrote it there, there were no parameters. Parameterized. I'm going to almost certainly misspell that. Anyway, okay, so that's the end of this. We'll go on to the second lecture because that's going to help inform you on your classwork.